Hey, Joe. All right. Perfect. So we are live now, I think. So yeah, thank you for joining us today on our bi-weekly Food for Thought. Today we have Blas Vicco. He's from Argentina. He lives in Peru. He's going to be presenting on artificial intelligence. So let's get to it. Hey, Vicco. Hey, Blas.
Yeah, here. Hello there.
Okay.
As can you say, I'm Blas. I'm a software engineer from Argentina, and I'm working with him in Annexus. I will give a briefly talk about artificial intelligence. We will go through these topics. So we will talk about what is it, when does it help us, where to start with it, and we will start with the discussion of a simple example. And if everything goes well, maybe the next time we will implement a simple example using neuronal networks. So what's artificial intelligence? To talk about it, we should define what we consider intelligence means. And it's actually not an easy question, not easy to find an answer for it. But we can say that there is many things involved in the process, and we can say that for start, we acquire information through our sense, and then we experience some events that happen in our environment, and through different methods we analyze them and we classify them, we measure them in order to compare them, and in that way we create knowledge, and we can say that we learn, and in that way we develop some skills. So from a very open point of view, in this thing that is we are related with, that is computer and programming, we can say that artificial intelligence start with the first programmable system. It's like we can imagine just like a calculator. The calculator sends our finger when we press a button, and the calculator recognizes that it's a number or an operator, and then it continue with the process of give us a result or an interpretation of the information that we put on it. So for that, we consider that there is some kind of artificial intelligence on it. This concept evolved and is directly related with the problem we are trying to solve. So we will discuss about a problem classification, and we will pay attention only in two classifications. For every event in the world, we have models that describe them, and this model, we try to use it to simplify the event and describe the behavior of that event. And we do it through a system of equations, and we can say that this system have a couple of behavior, like they are linear or non-linear, they are deterministic or non-deterministic. This is just a point of view to see these events in their reality, and we say that these events are linear if they accomplished with the superposition principle. This is a very mad thing. We will not go into it, but more or less, I have one of these principles in the screen that say if we have some function f, and we have some bars that we use it in the function, we can say that a linear system is that one that accomplish this condition. So if fa plus fb is equal of f of a plus b. Of course, in almost all the case in the reality, the problems are non-linear. And for that, we define models that simplify the behavior of this event to try to make it linear, because in that way it's easy to process them, and of course to find solutions to our problems. Other classification is related with the behavior of these events, and it's about deterministic or non-deterministic event. The deterministic event are those that we can, with 100% of accuracy, determine a future state of the event. So I give you an idea with this example, where f for let's say a state of A in the future, we can define it like an f of state of that element in the past and plus the current state. But a not deterministic event could be the weather tomorrow. So we are entering here to the stochastic event, and of course to the world of statistics and probabilities. No one have 100% of accuracy to determine how it will be the weather tomorrow. So we say, what is models, right? The models are a system of equations that help us to describe event in the reality. And for example, I have this function defined here. It's well known for the position of item that we threw in the space, and it's under gravity force. I will describe this in the next screen. But what I'm trying to show you is an example of a model that is deterministic, like this case, and a non-deterministic model that it could be talking about the same problem, but with a function that is stochastic. So in this example, let's say that I have a ball that is this circle there, and I'm holding it, and I will let it down. So to describe the position of that ball through time, we have this equation that is the one that I showed you before, that I say that is deterministic, where y0 is the current position. Let's say that is 10 meters. T represents the time, that is our bar, and it will change. B0 is the velocity in the states when time is 0, that is actually 0 because I'm holding it, so it's not moving. And then we have the part of the equation that describes the movement of the ball to the ground. This equation, it's depend of the value of t. So in t0, we know that is in the position 10 meter. And in tn, we can just replace the value of t to calculate the exactly position for Tn. So this model is deterministic, and we don't have any error to determine the position on En. But if we include other bars that happen in the reality, like the wind flow, this equation will not be more deterministic, and to solve the problem, it will be much more difficult. So these are the cases where we are applying artificial intelligence. We are using it for problems that are nonlinear and for problems that are non-deterministic. And we are doing that because instead of simplify the model, we want to use models that have a closer behavior than the reality. But to do that, we need to include a lot of bars that make really difficult to calculate values. Like in this case, the wind flow. So where to start? Now we know that when we should apply artificial intelligence, so we need to identify problems, and we need to define models that will help us to solve the problem. And we need to choose if we want to simplify the model enough to be able to calculate it easy, or if we want to be more accurate with the real behavior of the event and use more complex model like the non-deterministic or non-linear. So what we are talking when we say artificial intelligence, we are talking about a lot of technique or tool that help us to solve that kind of problem. To start to work on artificial intelligence, I highly recommend to have some basic knowledge and handle some concept related with the stochastic world. So I'm talking about statistics. Also about some concept that will help us to understand the world from a math point of view that called vector space. And it will provide us an easy way to understand. Actually, it will help us to do the analysis of the measurement that we take from the event. So vector space will help us to compare, and it will provide us other tools to measure different events or items in the space that we want to analyze. And of course, classification methods, because part of our intelligence do that. After, how we said before, after they analyze, we also classify, and in that way we can compare and do other stuff, like develop skills. We can just go a little bit back, and I can give you an example about intelligence. For example, if it's cold outside, we already developed an intelligence to analyze and measure that and develop some skill, like wear more clothes. So all these processes that we talk about, like sense information from our environment, analyze, compare, classify, and with that develop some knowledge and skills, is what we can do using these tools and technique. So very basic stuff. It's decision tree. It's something that we do a lot when we develop software. I will give you an example of this one, and we will go through this example to the other technique that I consider are very basic but but something that we need to know if we want to start working with artificial intelligence. So next to decision tree, we have fuzzy logic. It's this kind of thing are quite old, but as I say, I think it's something that we need to know if we want to do artificial intelligence. Vector quantization, it's really related with the vector space, and the perceptron that is a programmatically way to implement the functionality of a real neuron. Then another concept that we need to know is about learning. The kind of learning we can classify like in general like supervised and non supervised learning. So let's say that we have a basic problem. I have this question that I need to solve, that is, should I date her? So in this case, using decision tree, we can get an answer. To implement this case, we have an input to our system. Let's call her Lola. And we have a few parameters that we use to determine if I will date her or not. So let's say that the first parameter is she a girl? So in a decision tree, we can have only two responses, true or false. So it's like on-off values. So if we say that it's no, we already have an answer and we solve our problem. If she is, then the tree decision, we continue with the other branch of the tree, and we will get other answer. So this is very basic, and it's something that we do a lot when we develop. It's a very logic and natural way to understand problems. But in this case, we simplify a lot, right? So in the next case, that we are using fuzzy logic, we have the same input and we have the same parameters. But instead of have two possible values on off, we have a floating number that describe that parameter. This case, this technique tried to solve the problem of when someone asks us how cold it is. We exactly don't have and it is cold or it is not cold. We actually say it's more or less cold, or it's a little bit cold, or we use words like that. So there is not exactly on off on that response. So we do that because we compare and based off our experience, if we've been more cold than today, and we say maybe yes or not, and so in our brain we have an idea of coldness, but it's not something like black and white. So fuzzy logic tried to solve that things, and it will provide us values between or range. And in this case, I show you an example where for each parameter, we apply a function that will give us a value. And then if we use that values like calculate the average, we can get an output. So instead of the tree decision that is no or yes, we have maybe more accurate, but more fuzzy output. Oops, sorry. Oops. It's getting very slowly. I don't know what is going on in my computer. Okay, here we go. The next case that we need to know, like a basic thing, is about a space, vector space, and the classification through vectors. Let's say that we have our space. We define our space like all the people in the world. So we are excluding anyone that is outside of the Earth. And we will take only two parameters to simplify the chart here. So let's say that our vertical axis is a parameter if is she a girl, and our horizontal axis is does she love me. So with that two parameters, we can build vectors that are represented in the space like these ones. So let's say that this is the love of my life, and I would like to dare with girls that are close to this vector. The vector space gives us the tools to compare different items or person in our space and decide which one approach to our ideal. There are many different techniques to classify and define to solve models using this technique, and it's very interesting. And for example, for language processing, we use it a lot. And what we do is vectorize words, and we define a space of words, and we look for words that are close one of others, and in that way we can get some meaning on that chart. The next case, we keep with the same case, the same problem, is using a perceptron. It's a very basic concept of how a neuron works, and it does like this. We have our parameters that we ponderate with some values, and in that way we have an input that will go to our neuron or perceptron, and the perceptron have an activation function that will use the sum of all our inputs to give us a result of on-off. As you know, our neurons work in that way. They get some different electric impulse from outside or other neurons, and the neuron for inner function get excited or not, and it will produce another pulse of energy or not. So we can simulate that with a simple perceptron in computers, and what we does. So in this case, we have each way a ponderation that will multiply our input. We sum all that input and we pass it to our activation function to get the output on off. This, like a simple perceptron, doesn't look so powerful. But imagine all these perceptron configured in different layers and interconnected each other. Then we will get a really powerful tool that we can use to classify. Here we can introduce some concept about learning. If this way are fixed, we will not be able to describe a general behavior. So what a learning process involves is actually define some kind of process that allow us to modify this way and reduce errors. let's say that we initialize this way in some values and are fixed, and I introduce this parameter expecting a positive output, but this perceptron will not activate, so it will return us like I should not date her. But I know that I should, so I want to find a way to tell to this perceptron that it was classifying in the wrong way. So we create a measurement of error, and we send this error back propagating through the perceptrons, in this case as one, to fix the way in the direction of minimizing this error. So this concept is learning. So we are teaching, it's a supervised learning. So we are teaching to the perceptron how it should behave. So in future case, it will have a better response or more accurate response to different inputs. With this basic concept, we can go to the next level that I will recommend. You should start with MLP or multilayer perceptron. It's the thing that we were talking before about interconnecting different perceptrons in different layers. There are so many different structures that we can create, and for that there are many different multilayer perceptron types. All of them are related with different applications, and many of them are inspired on or natural neuron configurations, like in our nerve system or the configuration of the neurons in our eyes to perceive shapes are not the same that the one that we have in our cochlea or in our ear to listen. So they are interconnected in different way, and for that they have different behave, and they can classify different kind of inputs. Other technique, and it's very well known, and also it's an old one. It's called genetic algorithm. It's based like inspired in evolution theory, and we have genes that describe some behaves for different entities or vectors, and this gene can mutate through time, and also we can create some kind of function that will determine if a vector or item or gene will survive or not through time. It's used a lot, and you can find a lot of examples on internet. So I highly recommend to give a look to this technique. Of course, in almost all the cases, we don't just use one model to describe the problem. So we combine them, and we can combine, for example, multilayer perceptron with genetic algorithm, and in that way get better result to analyze or describe behaviors of the reality and solve problems. In the next presentation, we will go in more details through these ones. And just to think about it, I will propose you to give a look to the solved problem. And this is a simple case that very well known and use it for testing perceptrons and multilayer perceptrons. And it's an easy problem that we can solve with a tree decision tree technique, it say that if we have two input, A and B, with values that can be off, on, we have an output C that is described in this table. So with a tree decision, we can say that the A XOR B, it will be false in all the case that A is equal B. That's something that we can see here in the table. And it will be true in the other case. This simple problem, we can solve it using perceptrons and in a special configuration. And I will give you like tasks, homeworks to research about it. And in the next presentation, I will show you how to implement it using multi-layer perceptron. So that was all. Thanks a lot. And please
Perfect.
tell me if you have some questions.
Absolutely. So thank you, Blas. And yep, just let him know through Flowdoc if you have any questions. If you're watching the video on YouTube, recorded video on YouTube, just drop us an email if you have any questions. Thank you. Bye.
Thanks.